Hello, have you ever wondered why these all different countries live really different lives in really different economic conditions? As of 2025, there are approximately 200 countries, and all these countries have so different metrics about economic development and economic growth. Today, I am Nihat Sarpbilge, and I'm going to solve this issue by using some dataset tools including Excel and Access, creating a spreadsheet as well as creating a relational database. So the analysis that I'm going to be making is going to be consist of three main parts. First is going to be the simple analysis, which I'm going to use the simple and the basic Excel tools to have a general understanding and not that clear idea, a broad idea about the thesis that I'm going to present. With this simple analysis, I'm going to understand the dataset and the main points dataset makes to me, so I can have a clear thesis about the effects of my argument. My argument is basically economic growth and economic development's relation with the different countries' causes and effects. So I'm just going to investigate why different countries have all these different living standards and how these different living standards impacts each other with different indications. For example, some of the indications that I'm going to use is going to be education, health, life standards, anything. There's going to be approximately 20 indications and for approximately 3,000 rows. After the simple analysis, I'm going to have a better understanding and a clear idea about how I'm going to prove my point. So I'm going to go to detail analysis. Simple analysis is going to be from the Excel, and detailed analysis is going to be from Excel and exporting my Excel files to the Access. That's how I'm going to make my analysis. Through Access, I'm going to make some relational database, and with that relational database, I'm further going to develop my argument throughout the video. I'm going to prove my points about economic development and economic growth. The dataset that I'm using is highly reliable and trustable. It uses three main sources, which are World Health Organization, Oxford University's Official Data Initiative, and the World Bank. So these three are internationally known reliable sources that they are using. It's going to consist of the data between 2000 and 2015. The problem here, I want to make a self-evaluation that I wish the database has more values, including maybe 2025, but that was the secondary source that I found. But the primary source are quite reliable and trustable, as I have mentioned, because of the trustability of these international organizations. Now, as you can see, this is the source that we are going to use. It's from the Kaggle website, and when we check all the data, these are really trustable primary sources, like including World Bank, the World Health Organization, Oxford University, and usability is 10 out of 10. It's given by Kaggle. So I'm just downloading it as a zip file. Yep, I'm giving it life expectancy, WHO, World Health Organization dataset. And yeah, when I open the file, as you can see, there's approximately 21 columns and approximately 3,000 rows. I just expanded a bit to easier to analyze, and sorting years from smallest to largest, because I want to analyze this by year, and the countries alphabetically A to Z. So now I can see all the countries from A to Z in every years, because these are different data sets, each country has their own year data sets in the last 15 years after 2015. This pivot table I created, I am going to make an analysis of the regions throughout the years average GDP per capita. Now I add the regions, and not sum of GDP per capita, I'm changing sum to the average, because average GDP per capita is a better analysis. And as you can see, these different regions have different GDP per capita throughout the years, and with this graph we can visualize this change, and you can see the differences between the regions, the smallest being Africa and highest being North America. This was just an example of simple pivot table analysis, and as you can see, our source is really reliable because there is no any manual blank page in the cells of the countries. So we make this check 3 more times. We can make this check in the years. There's no blank, all the years are filled. This is already get a useful of 10 index, so we can trust this, but we just need to double check manually the trustability and reliability of the source. As you can see, there's no any blank source in this column as well.
We should be manually check to ensure the reliability. Let's make some checks as well for the different cells. Yeah, as you can, we just select some random cells in the schooling time, and as you can see, the difference is there's no any blank cells. All the things are filled because the data set explanation give us the full trustability. Now I'm going to make some simple analysis for the summarization of data, so we can learn this basic analysis of the data. So I'm just writing sum, average, maximum and minimum, and I'm adding the formula of sum, as you can see, between the life expectancy and the formula of average, which equals average and which between which rows, and the formula of minimum. I'm doing this for application for all of the columns. I'm just looking life expectancy, GDP per capita and population data for right now, the summarization, because these are the most important data sets, important columns for my analysis. As you can see, I'm just writing the formula of, I'm using 4 formula right now: the sum formula, average formula, maximum and minimum formula. These formulas shows the average of that column, sum of that column, maximum value of that column, and the minimum value of that column. So it can be it's going to be really useful for my analysis. Yeah, as you can see, I can see all the values right now in my data set, like sum, average. I made this pivot table and the other small summarization table to test the basic analysis. Now it's time to make more detailed analysis with the analyze data tool. Right now, when I select the whole data sets in analyze data, it gives me different pivot charts and pivot tables. I'm going to insert as much as I can to make this analysis. Right now, as you can see, I'm collecting all these ones, and after I select a lot of them, I'm gonna detail it by one, make some analysis and create a thesis from these analysis to prove in the relational database. Right now, the suggestions, I'm just using the suggestion they give. Yeah, I'm just editing the data on my own table. As I create a lot of pivot table with those ones, and this is going to be my simple analysis. And from my simple analysis, the thesis, the ideas that I'm going to get, I'm going to prove those ideas through my relational database. So yeah, right now I have a bunch of charts and bunch of pivot tables throughout this analyze data tool. As you can see, one of these pivot table. So the analyzation of these pivot charts and pivot tables are going to be on my report. As you can see, this is for the adult mortality, the sum of adult mortality per the region in every year. So this is going to give us a brief idea about different regions' adult mortality throughout the years. And I'm going to insert I'm going to make a detailed analysis in this table. As you can see, if I click the specific regions or specific countries, Excel's tool allow me to make a specific tables, like the smaller tables, to make more investigations, which I will going to use for different countries in the future. So it's going to be helpful. As you can see, this is the pivot chart we made. It's a really detailed one. Other one shows the economic development and the schooling time. So if when the schooling is increasing, the economic development is increasing as well. And this is also the economic status of development by GDP per capita. So as you can see, we can see the relationship between GDP per capita and economic status by development. And this is the infant deaths and by years, and as you can see, infant deaths are decreasing every year. This is going to be a really important data which I will analyze further. And also the under 5 deaths, significantly decrease, adult mortality decrease over time. All these values are decreasing recently, and this also says Africa adult mortality noticeably high. This is an important information as well. And this is economic status by developing countries accounts for the majority of under 5 deaths. This is a sad information. And the 2007 has a maximum alcohol consumption, and we can see the other years alcohol consumption, so we can investigate how alcohol consumption changed over the years. And European Union has a higher alcohol consumption by the regions. This is an important data as well. They have higher living standards but also higher alcohol consumption. That is really interesting. You would expect Africa, because as you can see, they have the biggest health problems, Africa to have the most alcohol consumption, but surprisingly European Union has the most alcohol consumption. So that's definitely a data that we're going to use in our further investigations. So right now I'm starting my detailed analysis. As you can see, detailed analysis is going to be the real deal in my project because I'm going to export this data to the Access in the future. And right now the first data set I'm going to do is economic growth. As you can see, I put like different economic status, like economic status developing, sum of population, average GDP per capita. I'm going to export these to the different tables by copying and pasting to the different tables, and then from there I'm going to export all these data sets. I'm planning to do 4 data sets to do Access so I can make more detailed analysis with those data sets. I'm copying them and pasting in a new data set, and my first Access data table is over, and I'm doing the second one for the more of an economic development indicators, like more health related. Economic growth, as I made the definitions at the beginning, is more of the economic, the money side, and economic development is more of the human development side, and that's why I'm putting like health data like adult mortality, alcohol consumption under 5 deaths, incidence HIV, sum of activeness, sum of life expectancy, sum of infant deaths. Those things are more of the health data rather than the economic data. And I'm changing those to, like, for example, if it's the sum, I'm changing to the average, and I'm adding row tables, and I'm excluding grand total because grand total has nothing to do with that, since this is the data throughout the years. First 2 of my data sets going to be about years, and the other ones is more going to be about the regions, so I can investigate both the time and the region, so I can make a combination between times and the region throughout my analysis. Yeah, as you can see, I'm opening a new data table. I'm changing the first of economic growth, and this is going to be a different one. So this is going to be the region table that I'm going to use. I'm going to pick different values. Let's think about it. Let's do the life expectancy maybe. Sorry, BMI and life expectancy. So I also will have primary keys and secondary keys in each of these tables, since they're going to be connected with the Access. I'm going to explain it more detailed when we go to that side of the game. I'm opening a new table. So as you can see, because we combine years and the region in this data set, it's kind of looks different, right? As you can see, there's like 2 main rows in the up, but I'm going to change this manually to make a simpler analysis. I'm going to say Africa, Asia average life expectancy, Asia average BMI. I'm going to make each data value, like each data column, for the region, so it's going to be more easy to analyze for me. For example, like as I mentioned, European Union's average BMI throughout the years, Africa's average life expectancy throughout the years. So we can investigate both regions and the years, not just years or the region, both time and the places on Earth. So we can understand these changes and understand the reasons of these changes throughout the year, and we can investigate how this impacted our analysis. We are especially going to focus on Africa because in our simple analysis we see that a lot of data table, a lot of pivot charts have mentioned about Africa we made from the analysis. So we're going to investigate in Africa specifically on our report. I'm planning to do some reports or forms for this. So this is going to be health indicators, as you can see, BMI and life expectancy. And I'm going to make my last table for the Access to import. I'm just selecting the table. Yeah, region, the same thing. This is going to be both region and years. This is going to include schooling and BMI. So since we got BMI in the previous one, this is going to be connected with the previous one through the BMI's primary key. You're going to see better when we go to the accessing those ones. I'm just fixing. Yeah, I'm doing the same thing. I'm just adding the regions on the each column, so which region in which time we can investigate it better to detailedly. This is the best way to do it because, as I mentioned, if we just do years, we're just gonna see the times difference in the whole world average. But if we do both regions and years, we can see both time and the region, how time affected regions or how regions affected time in each other. So we will have a better view and understanding of these reasons and the indicators, how they switch throughout the years and how they impacted throughout the years, so we can understand why these countries have different economic growth and developments values throughout these indicators. We have, as I mentioned, 21st column, and all these columns are different indicators like HIV, both health indicators and education indicators and economic indicators, so we can have an understanding of the effect
So
that's
in order
going
to
on the
continue
world.
our simple analysis, we're going to go to access bar. First, let's finish the simple analysis to accomplish the tasks criteria. I want to start with what if analysis. As you can see, Afghanistan's 2003 life expectancy is really low at 57.3%, which is like really low. And let's just check how would we affect if we want to make the average life expectancy throughout the year of 70. What should we change the Afghan? And as you can see, the change Afghanistan should have in 2003 3,000 years. So that's how small numbers affect the average. And Afghanistan is well below average, and it's impossible, as you may know. And the other simple analysis, if you want to analyze the most recent data, for example, instead of 15 years, just a 5 year, we can make smaller tables from the table tool that we can use. For example, let's do 2010 and 2015 adult mortality table. As you can see, this table only shows the 5 years data, and we can change the column's name, so we can make even smaller analysis. Instead of just doing the 15 years, we can make smaller analysis, so we can understand the impacts of these things through a smaller year basis. Years and adult mortality, as you can see, from 2010 to 2005, those are the changes. Change from 32,000 to 20,000, really low. I want to show how we can use filtering and sorting even more than what we do. So let's do the population by millions, and let's do some filtering, or yeah, let's do greater than 100 million. As you can see, we can see the countries that has population greater than 100 million throughout the 15 years. These are all countries that access to the 100 million years during the 15 years, or maybe it was even or more than 100 million people in the beginning of the set. And let's say how many of these countries do if we do the unfilter, we can see the countries in yellow because I paint them to yellow the table, so we can make analysis. But what about the alcohol consumption then? Let's make a similar analysis in the alcohol consumption. Let's say alcohol consumption between 5 and 6 liters. Which countries are? These are the countries that have alcohol consumption between 5 and 6 years. So I want to paint the cells to the red, right? This is the countries between alcohol consumption of 5 and 6 years. As you can see, some of them are similar with the 100 million. They both in the same shape. Both more than 100 million people, and alcohol consumption between 5 and 6 liters. So do the same analysis for the GDP per capita higher than 60,000. Yes, these are the countries during the 15 years that have GDP per capita get higher than 16 years. Maybe some of these countries get decreased or maybe increase a lot since us, because the relevancy is like 10 years old data set. And let's do the top 10 countries, and as you can see, it's all Luxembourg. So Luxembourg was always in the highest GDP per capita through this 15 years. That's what we learned. And below 10, Afghanistan and Somalia. Afghanistan was like the top below 10 in early, but now Somalia is getting less wealthy than Afghanistan. But these are like, even the metrics are before 2015, so it means they are not anymore. And higher alcohol consumption, as you can see, all Estonia. Estonia also have the highest alcohol consumption throughout the years. We made all this analysis, we learned all this information from this just simple analysis. Now we can, if you want, we can just analyze the recent data. I just picked 2015. This shows the countries that only have 2015 data set. And let's see the life expectancy top 10. In this year, these are the two top 10 life expectancy countries. The highest life expectancy in 2015, Japan and Switzerland. We can make life expectancy ascending, GDP per capita ascending or decreasing, and let's see which countries in the top 10. Australia, as you can see, has the 6th highest GDP per capita in 2015, which is the most recent data. And this is an important analysis. So Australia seems out to be really rich. I also want to make a table from this data. The table makes way more analysis way more easier to analyze. So yeah, I just made that table as you can see. So this is going to be more professional. I'm going to send both the raw data set and the table data set to my submission box, so you can see the both change. This is a simple data set and the table data set. Table data set doesn't have the summary table. The simple data set also has a summary table as well. And I want to save this data sets as the Excel XLSL, so that's gonna make it way more easier for me to do. And I want to add some passwords actually, so to protect both workbook and worksheet. I'm gonna add passwords. As you can see, I protect workbook by adding passwords for my raw data sets, and I'm going to do the same thing for my workbook, so they will both be protected by the that password. But this is not enough. We're gonna do one more thing to password all this data. This is just that this is protected data set. Now I'm going to do whole password. As you can see, this is the password that I'm going to use. Northmeet with and capital letter 2008. This is gonna secure both my table and my raw data set. Raw data set with the summary table. I'm doing the same thing, adding a password into the both raw data set and the table data set. So both professional and less unprofessional one. Both will have the password of Northmeet 2008, so it's going to be protected more easily. So let's make this analysis in different tables. As you can see, like the different pivot tables that I created for the simple analysis. I'm just doing the average of the sum of alcohol consumption between region, and it's 1534. Let's make a what if analysis that if we want that this average to be, let's say, 60,000, 1600, how your opinion, which is the highest that we discover, should change. And as you can see, European Union should have 5,284 liter of alcohol consumption in order to average to be 16,000. Let's make a change. What if we involve Antarctica as well? How will the average change? If we involve Antarctica, which doesn't have alcohol consumption, it's gonna change to 1400. And the other thing is other mortality by years. Let's make some analysis of these one as well. Let's make a standard deviation. This shows how it's different from the average, how like average of the far from average. The standard deviation is 3000, as you can see. This shows difference of other mortality between countries, 3000, like the average difference. Let's add some more data. If we expand this to 2016, 2017, 2018, 2019, and 2020. So if we expand the data set to 5 more years, and how will it change? Let's add the formula. Let's see the difference of adult mortality by each year. So how the adult mortality decrease or increase in every year, and expand this to the last 15 years. And as you can see, we now have the change in adult mortality for every year. So let's add some imaginary numbers. Let's assume that it changed with 226, and this is changed. How will it change? How will over time is going to be changed? Yeah, as you can see, the change is going to be 1000 after that. This is our assumption, and let's do some more analysis. For that, we can, if we want, we can record our actions. Like we can record the change that we want by the view screen and record action section. As you can see, I'm just adding even more data set to, let's say, get records and even get smaller of the numbers. As you can see, I can see the script, I can see what I did, and if we make this complete loop, we can even do more things in the future and make some if analysis. Let's say if average of alcohol consumption between B2 to B17, which are the original data set that we have, to 2000 to 2015, if the average of this number higher than the number that I am going to give, it's going to, I want to show to true, so we can see how big average is. So let's say if it's smaller than 850, let's say true. But if it's not, let's say false. Yeah, it's false. So we learned that it's smaller than 850. Let's see the average to test this. Is our analysis correct? Yes, the average, as you can see, is 652, 862. So it's, yeah, correct. That's correct. And also we can change the page layout as well. As you can see, I make some change. This is just going to give it better aesthetics and going to show it's better when we printing the data set. As you can see, I select everything like what I want to print and how it's going to get printed, because in the real life scenarios we have to print some of the data sets, and let's test how it's going to seem in printing if, let's say, the data set that we need to print it for giving a real life report. Print, yeah, as you can see, it's print like that. It's going to be a lot. There's going to be 500 pages since there's a lot of data, but it's gonna print like 3 columns per page when we print it. I also want to add some slicers. Slicers makes our analysis really easy. See, as you can see, I open a detailed analysis table that we are going to use soon for the access, and I want to add some slices for the specific values. I want to specifically do this for the Africa's average, since we discovered that Africa has like lower standards of living and lower economic growth than the most of the countries through our simple analysis. So let's add Africa's average BMI and Africa's average life expectancy and the other countries as well, but slices we're just going to use it for Africa. So slices basically just shows our the value, like the dot point, and it makes it way easier for us to see how the which values does these countries have throughout the years. Let's say Africa's average BMI and Africa's average life expectancy, so we can see the numbers, and when was Africa's average BMI, what was the life expectancy at that. We can see this analysis, so we can compare BMI with life expectancy through slices. Now I want to use conditional formatting. We actually kind of use conditional formatting, but not officially. What we did with the sorting and filtering was conditional formatting. It's basically shows like, let's say top 10% of the items, and it's just going to show top 10% of under 5 deaths. So which countries have the most under 5 deaths? As you can see, all the red cell countries have the top 10% of death, unfortunately. For example, Cameroon, which is in Africa, which also proves our theory that Africa is like lower living standards. All these countries have like below top 10% of under 5 deaths, unfortunately. So let's do this for the alcohol consumption, but let's do the above average. So which countries have the above average? Most of European countries should have it, because we discovered that European Union had the most alcohol consumption. Bahamas, that was interesting. These are not European, but as you can see, still most of the countries are the European Union. So that proves our point that European Union has a more alcohol consumption. Let's do something for life expectancy. Let's do greater than 70. Sorry, I believe I didn't pick the column. I'm just gonna do one more time. Yeah, greater than 70 years. And let's do this yellow this time. Yeah, as you can see, these are all countries have more life expectancy than 70. So these people averagely lives more than 70 years. That is a great data set that we can see how many people. As you can see, majority of the countries actually lives more than 70, but also there's a lot still not doesn't. Now I switch to Windows, and these are the detailed analysis that we use. As you can see, 4 of the tables I just imported into my Windows, and I open the cluster. So I'm just opening a new database called economic development and growth analysis. Is going to be an access. We're just going to import those 4 tables that we created early in the video. So from file, Excel, the tables that we created, desktop access, and the 4 tables. As you can see, we just made some pivot tables from our main data set. I'm putting primary keys at years for this one, and I'm going to give it name of the economic growth indicator one. Yeah, the first table is here. Let's add the other tables so we can make a connection. So for do the economic development, I'm doing life expectancy as my primary key for this one, because this is what I created first. Yeah, and this is going to be economic development. One is for growth, one is for development. We're going to connect all these data sets through different values. This is going to be life expectancy. And let's do the health and education indicators right now. Open our third table in Access, and I'm going to do the year and region health indicators. That's what I was going to open. Health is going to be the last, and my primary key, I'm just going to choose my own primary key, is going to be life expectancy for this one. Sorry, BMI for this one, and life expectancy for the other one.
BMI is about health, and life expectancy is about how much people lives. And the last primary key is going to be the life expectancy. Just opening, yeah. Sorry, the schooling is going to be the primary key because life expectancy doesn't have any connection. So schooling and BMI is going to our main connections, not life expectancy. My apologies for that. I just confused something. Yeah. So as you can see, we have 4 tables right now: economic growth, economic development, BMI, and schooling. I'm just gonna close these tables because we made these tables earlier. So I'm just gonna start a relationship between these tables. I'm gonna add economic development, economic growth. First, let's make connection between years to years. Years is in the economic growth is going to be a primary key, and in years and economic growth is going to be secondary key. As you can see, there's one-to-many connection, and right now make average life expectancy is our primary key in economic development. Like that was already our primary key in economic development. So I'm just doing the connection primary key as the secondary key in the BMI table, and in the BMI table BMI is going to be our primary key, and in the schooling table schooling is going to be our primary key, but schooling is not going to be connected with anyone, so it's just going to be stay there. As you can see, I did BMI primary key in BMI table to do connection with schooling. I just expand the data sets to see it like bigger. So I'm just gonna create some queries between all these tables. As you can see, we can see all the tables that we created and they have the relationship between each other. I'm just gonna add some queries. For example, let's do economic development average life expectancy, Africa's average life expectancy, Africa's average schooling, and Africa average of sum of infant death, sum of other mortality, average alcohol consumption, average GDP per capita. So these are, and let's view. Yeah, this is the main way we can do. I'm just gonna compare Africa's values to the average of the world because Africa is really interesting to see. As you can see, it's like have lower living standards than most of the countries, as we discovered earlier. So I'm just expanding to see better. As you can see, this table shows the comparison between Africa and the rest of the world in case of all these metrics like BMI, infant death, other mortality, those things. So I can just make some Africa's average life expectancy was higher than 60. We can see when was average life expectancy was 60. We can see other values of Africa and other values of the world. So we can compare how Africa was doing when Africa was doing like better than before year. How was the world doing it? So we see all the values. I'm gonna make a few more analysis. Let's see alcohol consumption higher to lower. So we can see the different countries life expectancy when it was the alcohol consumption was high. But interestingly, when alcohol consumption was high, average life expectancy of the world was lower. Was higher, and when alcohol consumption was low, average life expectancy was lower. This is a really interesting fact because, as we mentioned before, we expect this to be opposite, but it's not. So let's do the sum of other mortality less than 35,000. Wow, these are the times that other mortality was less than 35,000, and we can see the Africa's average life expectancy during these years. When it was higher, the Africa's average life expectancy was low, and when it was low, Africa's high expectancy was higher. So adult mortality and Africa has like opposite relation with. When adult mortality increased, life expectancy of Africa decreased. When life expectancy increased, adult mortality decreased. And we just make a report for this one from this query. As you can see, I named it query of Africa compression, and I'm making the report for this query. So the report of Africa compression. I'm just making some change in the design. I can if I want, I can make big change, but I'm just gonna make smaller change because it's already look aesthetically good, I believe. So I'm just going to change much. Yeah, we finish our report, as you can see. I'm going to do a few more
analysis.
So the second query I'm going to do is going to be more overall analysis. I add years, average GDP per capita, sum of population, HIV, incidence, thinness for 5 million years, under 5 deaths, alcohol consumption, and mortality. So it's going to be more health related analysis, and as you can see when I run, I see this table which gives all the values that I added. I'm just expanding it to make a better analysis, and I'm going to make some analysis. As you can see, I can see that throughout the years, average GDP per capita, sum of population, sum of thinness, and other health indicators, how they change. So I can compare how health impacts the economy and how economy impacts health. So let's do the sum of under 5 deaths. As you can see, from when we do the largest less to largest, years also change. So we can understand that year actually impacts the under 5 deaths. As the time goes up, under 5 deaths drops. So we're going to make some more analysis. I'm just going to analyze between 2007 and 2009 now. As you can see, during these times, which is economic crisis, that's how GDP per capita expanded. As you can see, we see a drop in GDP per capita. Actually, we don't see this drop in the other years, but because of this global economic financial crisis, we see this drop. And let's do some average GDP per capita, less than or equal to 1000. Yeah, so these are the times that average GDP per capita was less than 1100. As you can see, sum of population at these sums was 6 billion, and sum of thinness. So these were like really early in the beginning of the millennia. So we can see that sum of GDP per capita was lower than 1100 as beginning of millennia. Let's do the average alcohol consumption, lower to higher. As we don't see any order between alcohol consumption and the years, so we can analyze that years doesn't impact alcohol consumption throughout the time. So I'm going to say growth and development comparison, because this data set, this query compare these growth and data sets, and I'm just going to create some report for this. As you can see, there's a report that gives every year's average GDP per capita as well as population, so we can learn the every year's values and we can analyze this better in a professional ways. We can visualize the change through this report in more official way. So I'm just gonna say report, and yeah, we already have 2 reports, and now I'm starting getting even forms as well. So I'm going to make analysis between health and education indicators, schooling and BMI. As you can see, BMI is the primary key in the BMI table, which is connected to the secondary key of schooling table. So we can analyze impact of education and health. So I'm just gonna add BMI, world average BMI, world average schooling, and world average life expectancy, comparing Africa's average life expectancy and and European Union's average, and Middle East, and like different continents average life expectancy, so we can analyze better the life expectancies of the world. So this is more global analyzation. As you can see, now we have the world average of BMI, life expectancy, and values, as well as the every country's average of the life expectancy, every region's average of the life expectancy. We have Africa, Asia, all these regions average life expectancy. So we can see the difference between the regions, because we discovered that there's a big difference between the regions in terms of in the video. And now we will analyze the difference about economic development, because this is a life expectancy. So we can gonna see the difference of life expectancy. And as you can see, there's actually a big difference between each region as well. As you can see, world average of schooling is the higher. The countries when the life expectancy also get higher as well. So average schooling increase improves life expectancy as well. That's a good data thing that we learned from this dataset analysis. So in this query, I'm going to make some more analysis by filtering those through the logical operators. So let's say numbers when the world average life expectancy was less than 70 years. And those are the times. And as you can see, when the world was average less than 70 years, Africa's average was mostly less than 60. So this is an interesting value. Let's see. Yes, those are the 4 times when the world average was lower than 17 and Africa was even lower than 55. This is so interesting. So there's like 15 years gap between Africa, and look at the other regions. Other regions have way more longer life expectancy than Africa in all this case. So this is a theory that we also proven as well. Africa really have a lower life expectancy when compared to other regions. We can see this better in visual. So I'm just gonna name it query of life expectancy. Yes. Sorry, query of economic growth and development. I'm just change that. And yeah, so now right now we have 3 queries. I'm just gonna make a form and a report for the life expectancy query that I done. As you can see, I created my form of life expectancy over there. So now I'm adding a more new one, my last query. Again, it's going to be between BMI and schooling, which is health and education indicators. These are the primary keys of this table, so that's what I named them. I'm just gonna add the world average BMI, world average life expectancy, and the other countries' average of schooling. Average of BMI. So right now I'm doing the same thing that I've done for life expectancy for the BMI, so I can indicate the other countries' BMIs and their world average metrics, so I can compare the health indicators with the world's economic and other life indicators, so we can understand the reasons that causes these differences. So far we learned a lot of reasons like alcohol consumption, schooling, those things. I'm just gonna further develop these theory. I'm just gonna name this query of BMI which is body mass index. That's what it stands for. I'm just expanding the columns to make a better visual. As you can see, we got the BMI, well, the average BMI of each region in the world, so we can compare different values and life expectancy to BMI through these different regions and during different times. So let's do the BMI lower to higher. And as you can see, when BMI was the lowest, life expectancy was lowest, and when BMI was the highest, life expectancy was highest. This also correlates with the average of BMI of Africa, but as you can see, how skinny is Africa than the world average. This is an interesting findings as well. Let's say when the Africa's BMI was between 23 and 23.5. Yeah, these are times Africa's. As you can see, this is so interesting. When Africa's BMI was different between 23 and 20.5, other countries was mostly higher except Asia. As you can see, especially North Africa was really high with 27. Oceania was really high. So we see that Africa is really skinnier than the world average by two points. And life expectancy, when life expectancy was highest, the BMI was also high, but when life expectancy was low, BMI was also low. So we can conclude a relation between world average of life expectancy and BMI. These are impact each other through the time as well in every region. This when the world average changes, it's changing in every region. So I just filtered the table again to see the when European Union's average BMI, which has one of the highest BMIs, higher than 26. As you can see, when European Union higher than 26, Africa was on 23. So there's almost 3 points difference in average when with European Union was the highest times. This is an incredible metric that shows the difference between the countries in Africa and European Union, how they different BMIs. And what about the schooling? Let's look at schooling. When the world have the highest schooling, it also have the highest BMI as well. So as we can find a connection between schooling and BMI as well. This shows a wider connection between education and schooling. So I'm just gonna make a form. As you can see, this is the form. So this form has like 16 data, so we can see all the years of world average BMI and other metrics that we can. This is a great form that we can use to our further analysis. So I'm just downloading this as form of BMI. The reason I did form is because it's more professional and official and easier to analyze, obviously. I'm also going to export one of these forms as PDF as well in the future. So, and also I'm doing a report as well. Access allows you to do both forms and report. As you can see, this is the report. I'm just naming this report of BMI. Yeah, so now we have both form of BMI and form of life expectancy, as well as all the reports of the previous data sets. So as my final query, I'm just gonna make a query about schooling right now, so that I can understand the impact of education on all the other metrics that we include. As you can see, I just pulled up the BMI and schooling table, which is health and the education values of the regions throughout the years. So I'm just expanding those tables, this relational database. As you can see, these are connected and gives all the continents value, so we can analyze these continents better. So I'm just adding world average of the metrics, life expectancy, BMI, and schooling, and then I'm just adding the world average, the regions average of the schooling, so I can see how different regions all have different schooling age, how long they get educated, so I can analyze the education of world average compared to the regions, and can see that this region's different education levels also impact their health or life development. As you can see, this table shows all the regions average schooling times as well as the world average. I'm just calling this query of schooling. I'm also going to convert this to the four-man report as well. As you can see, this shows the world average schooling time and world average BMI, as well as world average life expectancy, and also each region's average schooling. So I can understand the other metrics impact of schools impact to the other metrics that I count. As you can see, North America and European Union as well as rest of Europe seem to have a higher education schooling than the other countries. We're gonna analyze it more. So let's set world average schooling lower to higher. When it was lowest, it was 6 years, and when it was highest, it was 8 years. But it's so interesting, guys. When world average schooling increases, BMI also increases, as well as life expectancy also increases. So they all follow actually a pattern. So we can say that there's a direct connection between education, life development, and the health indicators. And unfortunately, when world average of schooling was the lowest, Africa's was like almost half lower than that. This is so small. Let's make some analysis. When Africa's schooling between 3 and 4.5, which years were they? Yeah, most of the, oh my god, this shows really bad. When Africa's average was between 3 and 4, the world average was mostly between 6 and 7, and the other average was like 10s. As you can see, European Union's average was 10, other countries, rest of Europe was 10, North America was 11. This shows a big difference between countries, and this pattern can be seen in life expectancy and BMI that we before analyzed as well. So this shows that education, health, and all these values are actually connected to each other, which impacts the life of the individuals in those countries. So let's say when world average life expectancy, schooling was more than 8 years, Africa's was barely 5 years, and the life expectancy was also really at the peak. So when the schooling peaks, life expectancy also peaks as well. And rest of Europe seem to have more than average, both America and rest of Europe. Let's say when was America's more than 11.5. North America seemed to be really above the world average in education, as well as European Union and rest of Europe. By the way, we can export these forms that we created through PDF. I'm just also, as well as reports, I'm just gonna give some example of exporting it as PDF. I'm just exporting query of Africa comparison as PDF file and save export items. As you can see, I just saved it as a PDF. I'm also posting this in my link as well. And now I'm just adding
I will have
the
same password
as my access. I'm just
access
going
and Excel data set,
doing
which
this
is going to be
security
North Mid
concerns,
and
security
capital
issues.
letter 2008. I'm just gonna add a password. So with this password that we are going to do, our data set is going to be safely secured. I'm just getting info, password, Northmead 2008, and to verify password. Thank you very much for watching the video. As you can see, we made all this analysis and going to have one final conclusion, that we understand that unfortunately the region of Africa is under the world standards in most of the times, which is really is unfortunate. And on the other hand, regions like North America and European Union has higher than average world standards and life expectancy and all these metrics, both economic growth and economic development. We also discovered that economic development and economic growth are not these two separate broad concepts, but they highly related with each other and supporting each other in a cause and effect loop. in a cause and effect cycle. So any causes of economic development in affecting the economic growth. This is a great finding from the data source. And also one final interesting thing we found is alcohol consumption doesn't really have a big impact on health indicators, because as we've seen, European Union has the highest alcohol consumption by far, and they relatively are really good health indicators. Not relative, they have one of the best health indicators in the world. So that's an interesting point, because we know that alcohol is not good for human health, but it doesn't reflect to this data. So it's really interesting point. But otherwise, as we can see, we've proven, in summary, we've proven the relation of education to the economic growth and development, relation to the health to economic development and growth, and relation between economic development and growth in each other. So we proved three main points through our analysis with different countries. We use different tools. These as what if analysis, conditional formatting, all the other slices, the things, the pivot tables that we use, and there's way more things actually we can use. I want to make some evaluation about this. I believe we could have used more tools, and we unfortunately have to spend some less time on some tools and more time on this more simpler tools like filtering and sorting. These are like more basic tools. If I was doing this task again, I would spend more time on the detailed like condition analysis, those kind of tools, than the other ones. Also the relative frequency. Thank you very much for watching. This was all for today. See you.